So the two of you have pretty different takes on chip manufacturing. Can you talk a little bit about the companies that you work for, um, specifically what you're focusing on, just in case people don't know?
Yeah, of course. So Cerebras Systems is a 9-year-old company that manufactures AI chips, of course. The main difference with Cerebras Systems is that we actually have the largest chip in the world. It is about roughly this size of a chip. It actually has 900,000 cores and 4 billion transistors. Our main focus is really running super fast inference, which is how you would consume our services for the most part. If you go and you communicate with Meta, if you are partnering with IBM, if you are running using Perplexity or Mistral, you are probably using Cerebras backend. So the way that we optimize our software and hardware is we are really very much data center focused. Our goal is to be the best and the fastest AI compute company in the world for data centers, given the size of the chip and the way that we have really built our very, very bespoke ecosystem.
Yeah, so my name is Naveen Verma. I'm from EnCharge, and we are also very interested and concerned about the ways that AI is really stressing chips and the architectures that are required for doing its computation. We're targeting a little bit of a different space. We are a chip that I think is really unique because it employs a way of doing computation that we call analog computing. It turns out that most of the chips that we use today do digital computing, where we kind of pretend that the signals can be either a 0 or a 1 and nothing in between. And that's very good, because if you got 100 billion transistors on the chip, or in ways that Cerebras is pushing the barriers even further, all of these are going to have some noise, and you want all of them to work, and so you want to have a good signal separation. But you can see here that we are leaving on the table a lot of different levels in between that aren't being represented, and that leads to very significant inefficiencies. So the big breakthrough that is the reason EnCharge exists is we figured out a way to do this analog compute, which gives us significantly higher efficiency to do this AI computation, like a couple of orders of magnitude. We figured out how to do that robustly and scalably. And it turns out it came from some deep research. I, in addition to being the CEO, have also been a professor at Princeton University. So this was a breakthrough that happened in my lab around 2017. And so we're building chips and products around that sort of technology for computation.
Yeah, so the AI is growing so fast, and there's so much innovation happening in this space right now. Where do each of you see your companies going, and why are you working on this specific, it's not an edge case, but this specific technology right now? And how do you see that parlaying into the future?
Yeah, I think that Naveen will agree that the market needs to change. The ecosystem is changing. GPUs were not built for AI compute. It is coincidental that it's OK for that purpose. Really, there is a need to re-envision hardware to support the future of AI. And I believe that the two companies are pretty much after the same goal, which is really operationalizing AI at scale. At the end of the day, what we're seeing is we're seeing a lot of problems around speed, around resiliency, and around efficiency. So when you're thinking about AI agents, and you're thinking about multiple agents conversing one with the other and with other systems, things start to get slow. If you're thinking about consuming that from pretty much every other vendor today that is GPU-focused, you will get, if we're talking tokens per second, 50, 100, 150 tokens per second. NVIDIA just last week, good for them, announced that they have reached 1,000 tokens per second, while we are doing 2,500 tokens per second off the bat. And I think that this is really where the competition is headed. The competition is headed into high throughput, low latency, and you need bespoke chips. You need the ability to compute differently in order to meet the next generation of AI.
Yeah, so I just, first of all, completely agree and want to underscore the point that Naor made, which is that the way that we build and run chips to do computation for AI has to change. The ways that AI has stressed and expanded the kind of compute that needs to be done, it just cannot be done sustainably in the architectures that we've had in the past. And you also heard from Naor that there's so much potential from AI, and I think this is what's really exciting, that we really need to address the ways that it's stressing these use cases in all the different places and directions it could go. And the data center is a really critical one, and that's one where Cerebras has been a real pioneer in innovating new ideas. EnCharge is looking at a little bit of a different direction that we think is going to be really critical for AI, and it's in particular the ways that AI can get personalized and specialized, so for specific users or for specific use cases. Now, what's interesting is when you do that, you often don't necessarily want to run that AI in the data center somewhere. It's got a lot of personal information, a lot of personal signature and content in it. And it's both from a user experience perspective and from a user security and confidence perspective, often the best thing to do is to run it locally on your own device. It turns out to do that, though, now you have very, very severe energy constraints. And this is where energy efficiency, like EnCharge is aiming to address, really becomes critical. Now, there's also been another interesting trend in the industry, which is that as we've personalized AI, these massive models that have been the key to getting such good performance, these trillion parameter models, when personalized and specialized, can become billion, 5 billion, 10 billion parameter models. They can be dramatically reduced. So the interesting question is, now that they've gotten reduced, thanks to this personalization, can that also be the mechanism that allows them to be deployed on these edge devices? And that's where there's an energy efficiency barrier that needs to be overcome, which is what, of course, EnCharge is trying to meet.
Yeah, the idea of energy usage is so prescient right now. There's a ton of focus on how data centers are consuming so much energy and how is the world going to keep up. Is that something that both of you, like, is that front of mind with the businesses that you?
100%. At the end of the day, if you want to deploy more compute, if you want to provide faster and better experiences, you also need to be conservative in the way that you're consuming electricity. We are not infinitely scalable with electricity, which is why, again, redesigning chips, redesigning and rethinking the way that hardware is built actually helps in making sure that you're providing better and more energy efficient service. What we have learned is that through the usage of a very large chip, while it consumes more electricity than a smaller one, it is still much more efficient because the amount of traffic that needs to go on the chip itself is still substantially cheaper on the electricity side than actually moving out of the system and then into other peripheral systems and back into other chips. So really there is a lot of value in building one big chip that is much more energy efficient. And on endpoints and edge devices, I mean, anyone, you don't want to connect your mobile to the power every 5 minutes, so it's critical for people to have energy efficiency.
Yeah, I mean, the way that I actually think about computing is that it takes a resource we have, energy, and it converts it into useful results that we can generate. So in some sense, energy is the fundamental resource that enables, gets expended, basically determines the cost and sustainability of doing compute. So it's very fundamental. What's interesting is that it impacts all of the different use cases differently. In the data center, you need efficiency because the cost of the power to run it is high. And then interestingly, now that you've consumed that cost, the cost of removing the power, cooling it, is also very high. So in the data center, energy efficiency directly translates into economics and cost of ownership. In the edge, as Naor was mentioning, now we want to have these devices that are not tethered and they run off of batteries that need to last the entire day or more. And so we need to be able to do this AI in ways that are convenient and fit into our lifestyles. So the energy equation is fundamental. The more efficient you can make compute, the better and more accessible it'll be in a range of use cases. And how that plays out can be very different, which is what leads to very different kinds of architectures for very different kinds of use cases.
Yeah. So I want to talk a little bit about both of your companies had big news today in the past week. I don't know if you guys want to speak about that, but you have a new chip out, right, Naveen? Do you want to say what?
Yeah, look, it's in this field. Naor and I were just talking about this backstage. It's just there's excitement every day, right? There's new announcements from some portion of this ecosystem every day, and we're very glad and proud to have made a big announcement this morning as well about our chip. And I think really what this chip does is it shows this fundamental technology, which is really a transformative way of doing compute, using this analog in-memory computation, which frankly came out of decades of deep research, lots of papers published, lots of prototypes built, lots of things that didn't work, has now matured to the point where it is in products. It has been diligenced by customers. There are use cases that are demanding it. So I think our announcement of the first version of this chip, EN100, I think is really that kind of inflection point for us, right? Something that was a deep technological innovation now becoming productized and available to the world.
First of all, congratulations. That sounds amazing. I mean, I can safely say, you know, after 3 generations of our own product, getting a product shipped to the market is a big undertaking across the board, from hardware research to software research to supply chain. It is really, really a big undertaking. For us at Cerebras, we have just announced, so we have been the fastest inference in the market for quite some time. If you would like to consume anywhere from Llama 3.3 to Qwen or to DeepSeek, we are the fastest in the industry to fetch, use inference from. Last week, with NVIDIA's announcement on Llama 4 Maverick, essentially superseding 1,000 tokens per second, which is impressive for them and good for them, we have actually just announced that we have reached 2,500, so 2,500 tokens per second on the same Llama 4 Maverick. We have also announced that we are partnering with Meta, and we will be delivering the ultra-fast inference on the Meta cloud. So essentially, if you're consuming a developer essentially licenses and consuming inference from Meta, you will be essentially using Cerebras systems. And that is a testament to the way that we are operationalizing and shipping our chips to the market and actually enabling others to consume it. We have hundreds and thousands of developers that are currently actively developing on our platform, and we're just hoping that that would grow and everyone will benefit from our chips.
Yeah. Competition is good.
Competition is amazing.
Yes. So Naor, also your background is in cybersecurity. I'm curious how that plays into these chip architecture companies. And Naveen, I'd like your take too, but let's hear from Naor first.
Yeah, definitely there are a lot of challenges with security and hardware in particular. You know, if you're thinking about the desire to make sure that the entire stack, from the request that is coming in up to the chip and then the computation comes out, is really secure, that your data is not commingling with other customers' data, that the way that you are getting a response will never be the same response as another customer is getting if they have not been prompting the same prompt. Essentially, we have really built that and ingrained that into our hardware stack. We have also done the same for our software piece. And really the fact that we are consuming and we are dogfooding our own inference services allows us to really build an AI-native security foundation. So what we are really pioneering is not only the fact that we are securing our own hardware and software for our customers, we're also building a place where we can use AI agents for security purposes and really making an uneven playing field, which is an endless amount of attackers trying to attack our company and our customers, really a force multiplier by using AI to scale that amount of people to actually resolve and help dynamically mitigate threats.
Yeah, you know, I really think that the question of security and how we're going to secure the kinds of computation we're talking about is absolutely fundamental to AI being useful. So, you know, I really appreciate the sort of expertise and domain that Naor comes from, which is not my area of expertise, but just to give you my perspective on it, if we truly believe that AI is going to be put in charge of our most important workflows and most important activities, then it becomes that much higher criticality that we have security. And that, when you think about the complexity of these computing systems, cannot be an afterthought. It needs to be really foundational to the entire architecture at the hardware level, at the software level, at the block level, at the entire platform level, in all of these ways. And in fact, it progresses from there. Various use cases will be driven to the edge because of security reasons. The use cases that get delegated to the data center will have elevated bar on what security is. So this is really about taking a technology that has all the potential to be useful in so many different facets of life to now being something that we would actually feel comfortable putting in charge of those facets. And it's that critical. It will be a phase gate for AI to be able to be useful.
Yeah. Yeah.
If I can add one
Yes,
more
of
thing, I
course.
agree wholeheartedly with Naveen. I think that this is actually a better together type of a story. At the end of the day, most AI doesn't really need your sensitive data to get you some meaningful outputs, right? I don't need to know someone's personal information as I'm getting and reviewing something that is personal about him. The ability to actually run some computation on the edge device, stripping away whatever is not needed, and then conversing with a higher scale model that provides some better, faster, larger reasoning, that is a true future that we should all strive for, because that will solve two problems. It's two birds at the same stone. Essentially, we have the security and the privacy maintained on the device, while we're having those large-scale LLMs that are still not storing data and anything, providing the value that they should be providing, which is bigger reasoning and faster.
Yeah, well, that is a good segue into my next question, and probably the last question, which is the future. Like what you both see, say, 5, 10 years from now, how you envision your products playing into this AI space. Naveen, you
Naveen,
could
would you
go
like?
first.
Yeah.
Yeah.
Yeah, so I want to actually follow up from the point that Noor just
Yeah.
made, which is that in reality, AI is going to run across many different platforms and devices to provide a very seamless use case and experience for us. We will do things locally. We will do things centrally. I think the ability to envision such an architecture means that AI is going to be integrated in more and more critical aspects of our life, of our work, of our health, and so on. I do believe that a critical piece of that is going to be the ways in which AI will personalize. So I'm really interested in those applications, whether they're around wellness, whether they're around health, whether they're around education, whether they're around, sort of you name it, that really do attempt to optimize the experience and the value to the user, to a use case. But that really does require this vision of a hybrid AI that has its tentacles that can go seamlessly in all of these different directions in a way that can foster innovation around what these use cases and their delivery to customers will be.
Yeah, 100%. If we're looking into the current research in the field and we're looking into the future, we're definitely seeing a lot of optimization into existing models with the introduction of mixture of experts and other type models that try to minify and try to create more structure into the way LLMs work. We also see exactly the counterpart to that, which is larger models consume more and more and more and more data and become huge. And Meta is talking about their behemoth model that is already at the trillions of parameters, and we believe that that will continue to be the case. And what I'm hearing from all of my research peers is bigger is still better in our field. And we believe that there is a place in the world where that hybrid model, where you don't need bigger for everything, but you do need it for certain pieces, will be still the data center play. You will still have data centers that power huge chunks of AI. And in that tentacle logic, right, they will be able to service and be an extension where it's applicable, right? Or where businesses need to run something that is not necessarily running on an edge device. Think about doing transactional fraud. You're going into a gas station, you're putting your card. If we really wanted to apply LLM to that, we need to be so fast in order to deliver that it is really only the size and the scale of a data center to actually being able to provide that. And we believe that that's still the future. That future that is centralizing on the big parts and then the small parts that are at the edge.
Yeah. Great. Well, thank you so much. Very interesting. It's going to be interesting to see how things play out in the future.
Yeah. Thank you very, very much for having us.
Thank
Yeah.
you.